All right, welcome to the Chapter 9 lecture video number 1. I'm going to break the lecture for this video into fossil fuels, and then there'll be a second video for the Chapter 9 content about nuclear energy. So make sure that you watch both lecture videos for Chapter 9, and you're doing your fill-in-the-blank PowerPoints as you go along with them. All right, our objectives for the whole chapter are to differentiate between renewable and non-renewable energy sources, resources and reserves. You'll be able to recognize how and where fossil fuels were formed, identify the steps in making coal and how it's mined. You'll be able to describe environmental impacts of extracting the different types of fossil fuels. You should be able to explain how the cost to extract those fossil fuels have changed over time, and how the change in cost has influenced people's opinions about nuclear power. For nuclear power, our objectives are to describe the process of nuclear fission, describe a nuclear chain reaction, describe how nuclear reactors produce electricity, describe how basic types of nuclear, or what the basic types of nuclear reactors are, how do breeder reactors differ from those, and describe the steps in the nuclear fuel cycle. You'll be able to describe the kinds of radiation produced by nuclear fission. You can describe how our time, distance, and shielding related to protection from radiation. And you'll compare the effects of the accidents at Chernobyl, 3 Mile Island, and Fukushima Daiichi plant. You'll also be able to describe the process of decommissioning a nuclear power plant. All right, 9.1, major energy sources. Non-renewable energy sources are those whose resources are being used up faster than they can be replenished. And these include coal, oil, and natural gas. Renewable energy sources replenish themselves or are continuously present as a feature of the environment. And these are things like solar, geothermal, tidal, and more. They currently provide about 12% of the energy used worldwide, primarily from hydroelectricity and firewood. Let's compare resources and reserves. A resource is a naturally occurring substance of use to humans that can potentially be extracted. A reserve is a known deposit that can be economically extracted using current technology under certain economic conditions. Reserves are smaller than resources, and reserve levels change as technology advances, new discoveries are made, or as economic conditions vary, right? If the price of natural gas, say, goes up, then it might become economically feasible to access reserves that it were too costly to extract previously. All right, 9.3, fossil fuel formation. So most of the coal on the planet was made 300 million years ago when there were vast expanses of freshwater swamps. And when the plants died, they accumulated underwater, forming a spongy mass of organic material. And due to geological changes, some of these deposits were covered by seas and covered with sediment. Pressure from that sediment and heat over time transformed that dead organic matter into coal. There are different kinds of coal, and we can see lignite coal, subbituminous, bituminous, and anthracite coal. As we move from left to right on these types of coal, they have increased burial pressure, heat, and time, right? So anthracite is the oldest and most compacted of the types. Now, peat is something we find floating on the surfaces of kettle lakes. So like a bog would be covered in peat. You can buy peat moss to put in your garden, but it's sphagnum moss that has dead and decayed and been compressed over time. And it's also a really important energy source. especially in northern latitudes. All right, world coal reserves. So the recoverable coal reserves in 2019, most of the coal in the world is in Asia and the Pacific. Europe and Eurasia have the next most, North America over here, and then Africa, South and Central America, and the Middle East have very little of these reserves. All right, oil and natural gas. Oil and natural gas probably originated from microscopic marine organisms that accumulated on the ocean floor and were covered by sediments. The breakdown of organisms released oil droplets into the sediment, and muddy rock gradually formed shale containing that dispersed oil. Geologic changes caused migration of the oil into porous rock. All right, and here's a nice example of a cross section of the Earth's crust. You can see the different soil layers. There's an impermeable cap rock, so something that keeps the oil from being forced up to the surface naturally. So we'd have to drill through soil and layers here through that impermeable cap rock. Gas would be at the top because it's the least dense, right? Underneath that, we'd find a layer of crude oil, and then underneath that, there might likely be water, right? All right, changes in oil reserves. The proved oil reserves increase as new deposits are discovered and new technologies allow oil to be extracted that wasn't possible previously. And we can see over time, right, from 1980 till probably 2018, maybe, the oil reserves globally are climbing. Issues related to the use of fossil fuels. So right now, fossil fuels supply about 80% of the energy consumed worldwide. Coal is the most abundant fossil fuel. It's primarily used for generating electricity. The 4 categories of coal, which we saw pictures of earlier: lignite, subbituminous, bituminous, and anthracite coal. Lignite coal has high moisture, lower energy, is crumbly, and the least desirable form of coal. Subbituminous has lower moisture and higher carbon than lignite. It's used as fuel for power plants. Bituminous coal has even lower moisture and higher carbon content. It's used in power plants and other industries such as steel making. It's the most widely used because it's the easiest to mine and the most abundant. Anthracite coal has the highest carbon content and is relatively rare. It's used primarily in heating buildings and for specialty uses. There are 2 different extraction methods used for extracting coal: surface mining or strip mining, which is the process of removing material on top of a vein. It's efficient but destructive to the environment on the surface of the earth, right? Underground mining minimizes surface disturbance but is costly and dangerous. Many coal miners suffer from black lung disease, a respiratory condition that results from the accumulation of fine coal dust particles in the miner's lungs. And here's a nice little graphic of some of the different coal mining methods, right? So the underground mining methods, you might have an elevator that takes the miners down into a mine shaft, and they're accessing seams of coal under the surface. And then surface mining methods, you'd see a lot of construction equipment removing that surface material to get down to the coal layer. And there's a number of different landscape disturbances that can happen as a result of those surface mining practices. So here we see an unreclaimed strip mine. So they finished mining and just drove away, right? Here is a strip mine that's been reclaimed. So they were required to do some plantings, maybe smooth out the surfaces so that an ecosystem could reestablish itself. And this would be a nice example of succession, right? Maybe even primary succession if it's all just bare dirt when they're done. All right, environmental issues, subsidence. We'll talk more about this one in class. Let's move on for now. We'll circle back to that one in class when I see you next week. Coal use, transportation, and pollution. So coal is bulky and causes some transportation problems. The mining itself creates a lot of dust pollution, and burning coal releases pollutants. For example, carbon dioxide, sulfur dioxide, and mercury. Millions of tons of material are released into the atmosphere annually. Mercury is released into the air when the coal is burned, and increased amounts of atmospheric carbon dioxide are implicated in global warming. Sulfur dioxide causes acid rain or precipitation. So some environmental issues associated with coal mining are acid mine draining, which happens when oxygen, water, and certain bacteria cause the sulfur in coal to form sulfuric acid. All right, the energy content of oil is more concentrated than what's in coal. It burns cleaner and it's more easily transported through pipelines. These qualities make it ideal for automobile use. Locating and extracting oil causes less environmental damage than coal mining. Once a source has been located, it must be extracted and transported to the surface. The primary recovery methods used are if water or gas pressure is associated with the oil is great enough, then the oil is forced to the surface when a well is drilled. So once we penetrate that impermeable cap of rock above the gas and oil reservoirs, pressure could force the oil up to the surface. If there is no pressure to force the oil up, then we can simply use pumps to pump it to the surface. About 5 to 30% of the oil is extracted depending on viscosity, so like how thick it is, and geological characteristics. Secondary recovery is when water or gas is pumped down into a well to drive the oil out of the pores in the rock. And this technique allows up to 40% of the oil to be extracted. Tertiary recovery is when steam is pumped into a well to lower the viscosity of the oil. Aggressive pumping of gas and chemicals can be pumped into a well. And these methods are expensive and used only with high oil prices. All right, some of the extraction methods include offshore drilling, like the Deepwater Horizon drilling rig. There's also secondary recovery, where they're pumping water in on the sides here. So there's water injection on the left and the right. And that water helps to force the oil up into the oil well. Now, after it's been pumped to the surface, oil needs to be processed. And we call that processing being refined. Multiple products can be produced from a single barrel of crude oil. And we know that sometimes there are oil spills. Accidental spills only account for about 10% of oil pollution, and that from shipping. And the effects are still poorly understood. Here's a picture of a giant oil tanker. This is the Trans-Alaska Pipeline. Environmental issues. Oil spills from tankers. It's estimated that worldwide, only about 10% of human-caused oil pollution comes from tanker accidents. almost half of marine oil pollution comes from natural oil seeps in the ocean, which is interesting. All right, and we have seen a trend in the decline of spills from oil tankers over time. Let's talk about natural gas next. The drilling operations to obtain natural gas are similar to those used for oil. It's hard to transport, though, and in many places it's burned off at oil fields, but new transportation methods are being developed. So natural gas becomes a liquid at negative 126 degrees Fahrenheit, or if we compress the volume to 1/600. The public is concerned about the safety of natural gas loading facilities, so they're located offshore. And this is the least environmentally damaging fossil fuel. It releases less carbon dioxide gas than coal or oil when it's burned. All right, and that's where I'm going to wrap up lecture video 1 for chapter 9. Make sure that you watch lecture video 2 for chapter 9 to learn about nuclear energy.